Welcome to my channel. Today I'm going to discuss how we can use the flat Earth to calculate how high in the sky the star Polaris is. So, how can we do this? Let's start smaller. Let's assume we are standing next to a pole. I know what you mean, but I was thinking more along the lines of a flagpole. You look up at the pole and it is really tall, and you can never reach the top of it. However, you still want to know how tall it is. Obviously, a yardstick won't do it. We do have a tape measure and a method for taking angle readings, and as it turns out, that is all we need. Here's why. The base of the pole forms a right angle with the ground, and by moving a known distance from the pole, we can create a triangle with the pole being one of the sides. This triangle naturally has three sides, and you can see that angle C is 90 degrees. That makes this a right triangle, and as you should know, if you sum all the angles inside a triangle, that will come to 180 degrees total. Once you subtract the right angle's 90 degrees from that total, you have two angles remaining that will combined add up to exactly 90 degrees. I'm sure you are with me so far. The basic trigonometric functions tell you exactly how the other two angles of the triangle relate to the lengths of all three of the sides of the triangle. The sine of angle A is found by dividing the length of the side opposite of the angle, labeled lowercase a in this diagram, by the length of the hypotenuse, which is labeled lowercase c here. As handy as this is, there was a time, like when I was still in high school, when getting a good value for the sine of an angle took some work, looking up values in tables, which were not exactly what you needed, and so you had to calculate the values which landed between the given values. Today, you can avoid the significant number of minutes of work that required by simply punching in a value for the number of degrees on your calculator and hit the sine button, and back comes a very precise value for you to use. Excellent. Even nicer is how you can put in a sine value and your calculator will return the number of degrees in this angle immediately. So, for all three of these trig functions, if you know the value of any two of the three parts in the equation, you can find the one you don't have yet. Using these functions, you can work mathematical magic with a right triangle. I also want to touch on the Pythagorean theorem because, as you probably know, you can use that formula to find the length of the third side if you know any of the other two sides. With these tools, we can now calculate the height of our flagpole. We'll start by walking away from the pole until we reach the point where the angle from the ground to the top of the pole is exactly 66.5 degrees. The reason I picked this particular angle will become apparent later. Of course, you know that the remaining angle of our triangle must be 23.5 degrees, since the total of all angles must equal 180. Using our tape measure, we find that we are now standing 43.5 feet from the pole. Referencing our tangent function, we now have an equation that will allow us to calculate p sub l, the height of the pole. P sub l equals our distance away from the pole, L1, times the tangent of 66.5 degrees. We measured L1 and it came to 43.5 feet, as I mentioned, and our calculator tells us that the tangent of 66.5 degrees is 2.2998. Multiplying them together, we get the height of the pole, which is 100 feet. Now that was a lot easier than climbing the pole to measure it, don't you agree? But let's double check our work. We'll make some measurements from another location and see if the results still match. First, we will walk out even farther away from the flagpole until our angle measures 23.5 degrees. Using our tape measure, we find that we are now standing 230 feet from the flagpole. Once again, using our trusty tangent function, we have our formula. We measured our distance at 230 feet, and our calculator tells us that our tangent of 23.5 degrees is 0.4348. Multiplying them together gives us 100 feet. Our results? We got the very same answer both times. Therefore, we know the flagpole is 100 feet tall. But how does this tie in with the flat Earth? We can use the very same tools to test the flat Earth model by measuring the height of the star Polaris. If you go to the North Pole, I should mention that in case you still believe in the big guy with the red suit, I don't want to spoil your magic here. But if you're a bit older, the visits shouldn't be too tough to take. But once you are up there at 90-degree latitude, we will be looking up at the polar star named Polaris. But that is like standing at the base of the flagpole and not being able to reach the top. Let's move away from the North Pole far enough to where the angle from our horizon to Polaris is 66.5 degrees. Sound familiar? We know how to do the calculation now if we have the numbers to work with. We measured the angle, and we also tracked our travel and found that we had to go 1,621 miles in a straight line due south to get here. And of course, we are now standing on the Arctic Circle at 66.5 degrees north latitude. Sailors have known for centuries that they could determine their latitude by finding out how many degrees Polaris is above the horizon. The number of degrees they measured gave them their exact latitude north. Longitude was a lot tougher to find, but finding your latitude was easy in the northern hemisphere. Moving forward, we now know the value of L1, and we know the tangent of 66.5 degrees from our previous calculations. And so all we have to do is to multiply them together to get the height, p sub L, for Polaris. And we find that here on this flat Earth, Polaris is 3,728 miles above the North Pole. Just like before, we have to double check our work. So, it's time to shed all of those furs and heavy undergarments because we, my friend, are going tropical. Moving south farther and farther, we hit the Tropic of Cancer. Grab a drink to keep cool and let's get to work. We have now reached the point where we must break away from the fun and tropical games at night and look up at the sky to see that Polaris is exactly 23.5 degrees above the horizon. This is the same angle we used at the flagpole, but this time our L2 distance comes to 4,596 miles from the North Pole. So let's run the numbers. The things we have to sacrifice in order to pursue knowledge. Our equation leads us to multiplying 4,596 times 0.4348. We are now getting to feel right at home with this stuff, right? We find that at the Tropic of Cancer, Polaris is 1,998 miles above the North Pole. But wait a minute, what happened? Unlike with the flagpole, where we were using a bit of flat ground as our base, we find that the ground below us has played us false. At the Arctic Circle, Polaris was 3,728 miles above the North Pole. But at the Tropic of Cancer, it is only 1,998 miles above the ground. We have already validated our math as being correct. So what failed us? It was our assumption that the ground was flat and not curved. There's no possible way that this could happen on a flat Earth. But you would expect it if you were traveling on a globe. End of story. If you enjoyed the video, please click like. And if you haven't subscribed yet, please do. If you click on the bell, you will also receive notifications when I put up a new video. Thank you for watching, and I'll see you next time.